So can you see my presentation?
Yeah, head into the screen. Please start. Thank you.
All right. So the topic of the presentation is the techno-legal aspects of use of AI and blockchain for digital sovereignty in critical infrastructures, primarily the power systems. So this is a short background of myself, but I will just skip this for the sake of, I would say, time. So the agenda, I have the smooth introduction to the digital sovereignty topic and explain the importance of critical infrastructure, especially power systems as primary critical infrastructure, and energy cyber physical systems, and step by step the use of artificial intelligence and distributed ledger technology for power systems safe operations. The last part of the presentation is about the techno-legal aspects and future works. So basically, the digital sovereignty is a very large topic, especially this is not only limited with the European perspective, but since most of the, I would say, the law standards that I will be referring to will be about European Union, I just prefer to start as a reference point. So there are a bunch of activities and actors in the landscape. There are the legislative landscape and also large companies, and the single market strategies of European Union, which allows to transfer the services and goods within the European Union flawless and seamless in terms of, I would say, any type of market regulations. And this is also related to digital services and markets. On the other hand, the ethical AI, cybersecurity aspects are becoming very important, and also digital sovereignty aspects are also we need to take into consideration. This topic is quite large. It is difficult to, I would say, summarize everything in one slide, but long story short, there are different aspects of digital sovereignty. One is about the data sovereignty, which is about where the data is being processed and stored and who has the control, and GDPR regulations, e-privacy, and their American and other countries' equivalents can be counted as legal standards. And the technological, I would say, sovereignty, which is about ICT, information communication technologies usage, let's say the base stations or any type of hardware in critical infrastructure communication. And we have AI models, AI data, and different type of aspects as well. So, which is about where the ICT is used. Why power systems is very important in terms of critical infrastructure. According to European Union, there are 12 different categories of critical infrastructure, including space, water systems, and most importantly, the power systems. In United States, it's slightly more than 12 categories. If I'm not mistaken, 17 categories are defined by law. But most importantly, the power systems as enabler and foundational part of each and every critical structure, it has a priority in terms of regulatory issues like European Union Directive on Resilience of Critical Entities. It is defined as the primary and I would say critical infrastructure because the telecommunication, water systems, health systems, financial systems are also connected to power systems, and also generative AI, you know, the discussions about the, I would say, bit miners, or more important now, the data centers where the generative AI models are running. So such kind of applications can also be explained using cyber physical and social systems framework. Basically, the bottom layer is the physical systems, starting from, I would say, if it's the power systems, from bulk generation units, transmission companies or systems, distribution systems, until the consumers. So there is a value chain starting in these actions, and renewable energy systems, electric vehicles are also located in different parts. So basically, whatever we see in terms of like in the physical systems are analog world, it's substation electric vehicles where we see electric power. Once it is converted to zero and ones using sensors like smart meters or temperature sensors, then we have zero and ones, digital world starts here, and the telecommunication layer is responsible to transmit that zero and ones digital signals from point A to point B. We have hundreds of telecommunication technologies, and most important, layer number 5 is the topic of this presentation as well, the information and data layer. Blockchain, quantum computing, AI is located here. In the upper layers, we have energy policy, law aspects, regulatory aspects, and also business layer, which are in the social science domain. So it's an interconnected and quite complicated type of realities in our real life. So basically, similar to the power systems, our communities, cities are also connected to the same system. We have smart homes, smart communities, smart cities. You can extend the spectrum accordingly. And information communication technologies can also be explained as a nexus of IoTs. IoT refers to Internet of Things technologies. Primarily, AI and DLT are the enabling technologies in this case. Another aspect, if we are referring to prosumers and consumers, it's about individuals. And if we are talking about, let's say, bulk generation, let's say nuclear power plants, hydroelectric power plants, the individuals are not the main topic here. This is the companies. If we are referring to any type of use case, data leakage, cyber attack, or different type of incidents on the personal data, like electric vehicle load profiling or energy using load profiling of a person, individual, or customer, it's about digital privacy. But if we are talking about, let's say, the safeguarding transmission systems, distribution systems, or similar power systems, it's about national security. So there is a certain balance of national security and individual rights, and cybersecurity goes on both directions almost equally. Of course, AI and blockchain technologies are the emerging technologies, and in some use cases, they interfere to each other. Personally, I have been working on the use of AI in power systems for almost 25 years. My PhD was on that in Fraunhofer Institute 25 years ago, completed and applied such applications in real life applications and also scientific work several times. And recently, we start using, of course, like many other researchers, the use of generative AI in the power systems. So forecasting is one of the applications where the AI is used, especially wind power forecasting, and safeguarding the supply-demand ratio is a very important aspect. If there's an issue in terms of supply-demand ratio, or if there are some failures happening like n-2 beyond the n-2 principle, basically if there is more than two components of the power systems are disconnected from the, let's say, power systems, and you may have the blackouts, like the Iberian Peninsula blackout, which happened, and then more than 12 billion euros, I would say, the financial loss happened. There is a very fine difference between the faults and the cyber attacks. Basically, the faults happens randomly and cyber attacks happens intentionally. As we discussed, we have different layers, like in power systems, we have physical management of the or scheduling of the power systems, but at the same time we use ICT, information communication technologies, like LTE, 5G technologies, or fiber optic. So, and some of them are related to the physical world, and some of them are cyber world, and some of the failures happening in the power systems are happening during the normal operations, but some of them are cyber attacks if they are intentionally done. So there is a very recent principle, which is also called AI Trust Risk Security Management. Basically, it's also mentioned in the Gartner's hype curves. Long story short, it is the nexus of AI trust, risk management, and security management related issues, and where the legal aspects are also coming into the game, especially with the emergence of generative AI, it's becoming more important. So I think the more important thing is the AI systems have design process, modeling process, input data, output data, but we have training and testing data as well, so that AI systems are helping us, but at the same time, they are constituting a certain level of risk for the attackers as well. The attackers can be individuals, group of peoples, or the states. As mentioned, this is the life cycle of the AI systems. We have training system, we have the AI models. Once they are ready, they are deployed on the power systems or any type of industrial area. And there are different type of attacks, like you can poison the data, you can poison the model, and there are different sub examples of that. Our research team in University of York and NTNU is working on such kind of AI-based threats, especially applying on cyber-physical social systems. The AI tourism has explainability, adversarial attacks, data protection, and animal detection type of, I would say, technical and techno-legal aspects as well. All these elements have the legal, I would say, articles in the European law. Actually, if we are referring to the measurement, the phaser measurement units are very precise measurement units, which is used in the power systems, which measures very important elements of the power systems. In one of our studies, we developed the Texas data from United States and ran the animal detection algorithms, which intended to detect the normal anomalies, not the cyber attacks. In this paper, if you are interested in, you can take a look at this. This is a Q1 journal. Then in that journal, as it is indicated here, we have 3 layers of AI applications. Basically, the first layer, the animal detection layer, is used to detect any type of normal anomalies on the power systems. We use 4 different type of AI algorithms. And very importantly, we had the second layer of AI algorithms. Basically, they are attacking the first layer of AI algorithms. So the algorithms are fighting each other and then attacking the normal functional AI algorithms. And the third layer, they try to mitigate. So what we observed is some of the AI algorithms on the first stage are very accurate in terms of determining the anomalies, but they are very fragile against AI-based attacks. So that means, as a summary of this paper, we identified that the digital immunity of the AI models shall be considered as a holistic approach in addition to the normal operations and their key performance indicators. The AI is an opportunity, AI is a threat, and it can be also mitigated. The techno-legal aspects, by the way, has also its own, I would say, aspects. But before it, this is the blockchain working group that we developed legal standards here with our extended group in the last 7 years, P2418.5. I'm the vice chair of this group. And we had more than 14 articles, even Q1 articles written in this field. This is another article where we summarized use cases of energy blockchain and did a market survey and checked which of the use cases had been successful in the last 5-6 years, but also normalized the importance of them. So with the other groups, we also took a look at the use cases of energy applications like you can see here, and also double-checked if the cybersecurity aspects of the blockchain is also strong enough, or can it be used to safeguard the power systems in terms of cybersecurity and digital privacy as well. These are the other articles that we published about the smart contracts standardization and cyber secure operations and privacy aware, I would say, applications of smart contracts. And similarly, the cybersecurity aspects are elaborated in more detail. The legal aspects are a very long topic, but I can only use the rest of the time to elaborate the most important elements. The AI Act is one of the most important legal standards in European Union. Basically, we have different layers of risks. The Article 5 related issues are related to unacceptable risks like behavior manipulation, social scoring using AI, and also the high risk Article 6 related applications are high risk to health, safety, environment, and fundamental rights, and also the critical infrastructures operations are also related to those activities. Long story short, European Union makes sure that human insight and control supposed to be integrated and embedded in critical infrastructure and critical use of artificial intelligence. Not necessarily for everything like spam filtering, but more importantly for Article 5 and 6 related topics. When we turn back to the nexus of smart systems, critical infrastructure like energy, of course, it's related to energy law. And if it's about renewable energy systems, environmental related laws, and also the IT laws like cybersecurity, digital privacy, and ICT related laws like GDPR, Network and Information Systems 2 Directive, which is about cybersecurity, AI Act as mentioned, and also CER, Critical Entities Resilience. In order to have a very, I would say, safe operations in terms of considering the techno-legal risk, it is very important to analyze the impact of artificial AI systems that process personal data for I would say digital privacy and cybersecurity aspects, like GDPR-related articles like 17.5 and the other articles related to processing to the personal data. But also we have to consider the AI acts and also use of it. Like we need to minimize the risk and the trustworthiness of the systems supposed to be there, like Article 9 and 10. And transparency and explainability must be also there. And also, as a summary, for cybersecurity-related applications, NIS2 directive and also the CER, critical entities, Article 2 and other articles supposed to be investigated in a holistic way, but at the same time, step-by-step cyber techno-legal aspects supposed to be investigated at the same time. So we work on different aspects of cybersecurity usage, as mentioned, for blockchain technology. And as a concluding remark, applying privacy, security by design principles, if we are designing digital platforms for energy systems or any similar type of critical infrastructure, we need to consider the privacy, security, and similar aspects by design, not after we develop the solutions. And we need to consider the legal standards at the same time. Of course, the use of AI, DLT, and other emerging technologies might help to limit the risk for the digital sovereignty and safer infrastructures, and we need to consider the full spectrum of techno-legal aspects when we are designing the systems or operating the systems. So this is the end of my presentation. I hope the timekeeping was under control, and if there will be some questions, I will be happy to answer some of the questions as well.
Oh, thank you so much. You even was a bit faster than we expected, but yeah, I guess you covered like a lot of things, and in every slide there could be much more to dive deep into. But maybe as a question from our side, what could you say about specifically for Ukraine? You know, do you know of any suggested steps we should look at in our situation?
First of all, I think the peace is the emerging wish for everyone. That is I would say, the most important aspects. Of course, especially if you are considering the after peace type of normalization process, especially rebuilding of the country. As mentioned, the critical infrastructure is one of the most important tools and elements of any state, which can be power systems or chemical systems like I would say natural gas, petroleum, and all type of energy systems. But at the same time, all connected systems together, like telecommunication and others. I think restructuring such systems starting from the priority would be the most important case. Identifying, I would say, the damages which already happened is the key issue. But at the same time, I think the wars are, everyone agrees that it's not the best case. But after war, it gives the good opportunities as well. If you look at I would say, if there is any positive part of it, it gives the opportunity to restructure in the most available and modern way as a hope and also the future step to the country. I believe if we consider especially the colleagues who are active in IEEE from Ukraine, they are, and also you have Ministry of Digitalization and similar type of operations, which is a quite strategic tool and resources. I think regaining I would say the experts, the Ukrainian experts, which are inside the Ukraine and outside in the normalization process would be the HR, human resources related type of priority. I would say that is another aspect. And also, since I'm an educator working in the university. So we shouldn't forget about the rebuilding the universities and then reinvesting the next generation with all levels of education, K-12, but at the same time university level as well, and regaining such HR and other experts remotely, or I would say in person, and then rebuild the critical infrastructure, again, including from power systems, but also the digital one, in a systematic way, may potentially make the country even more stronger than before war conditions. These are the summaries what I can mention. Yeah.
Okay. And also, I was looking a bit into the DAO and cooperative models, like for the energy communities. I was curious from your perspective, like there are, I think, some experiments going, but which experiments or maybe already existing system utilizing DLT could be shown as a great example to be copied?
I think the DAOs are quite interesting and emerging areas, which is also built upon not only distributed ledger technology, but also potentially AI and generative AI as well. I think the full discovery of the feature applications in terms of what the new technologies offer, again, the use of generative AI is a game changer, is one of the most important aspects. The second, DAOs also can be applied for building or operating the critical infrastructure as well. It can be state-owned larger systems, but at the same time, depending on the market structure, you can also have peer-to-peer energy trading or different type of the use of such applications with normal users and their participation as well, right? Their surplus energy can be traded if they have photovoltaic panels, for instance, to their utilities or neighbors. Of course, not all the states and countries allow this, but there are regulations which can be used. And those, of course, the smart contracts can be integrated, as many experts know, and also the cryptocurrencies as well, and also the fiat currencies or other currencies in parallel. I expect, like many others, there will be new type of DLTs. I'm not only referring to central bank moderated ones, but there can be new types of it, which is also anchored with the physical commodities as well. I think these are the features that we will be seeing, that it's developing in Web3 environment, but at the same time, the physical equivalence of it will be very important as well, like commodity tokenization. And if we are talking about power systems, they are almost fully physical, right? Tokenization of it is one aspect, but operation of it in a safe way, a trusted way, is another aspect as well. Yeah.
And have you seen maybe some big grids or corporations utilizing blockchain, not for trading, but for those controls or something? Do you see this? Can you share more?
Yeah, sure. I was referring to one of the papers that I was sharing with you. Let me just try to share that screen again, so that it can be a good opportunity to maybe spend a couple of seconds time on that. So we investigated more than 350 references and companies. It is one of the largest, I would say, papers written in that area. I will share the screen right away. Yep. And also the working group, which is organized by IEEE, we spent 7 years and identified several use cases, and we summarize, let's say less than 10 use cases where which has more, I would say, potential. And some of the use cases, we realized that these are not existing; these are just hype, like many other technologies. Peer-to-peer energy trading was overhyped. And this is the paper that I was referring to, and this is open access. If some of the audience have an interest, you can also take a look at this work. So what we did here, we summarize the companies. This is market survey, but at the same time studies and papers, in total 350 approximately references. And we had experts from all over the world, as you can see here. Some of them are under IEEE and distributed in many places. We normalize the outcome. So that means we ask the experts with different surveys, and then if it is really peer-to-peer energy trading is the most important use case. And we also observed that most of the startups are not existing anymore. It was the hype, but we realized that some of the use cases like operations of transmission systems, I would say operations or different type of businesses are more important than only just peer-to-peer energy trading. So more detailed information can also be observed here. Some of the use cases are technical and some of them are economic or just like financial. So mix of them are also possible. So it's not pure technical, it's not pure financial. Most of the use cases are techno, financial, or economic type of use cases. Yeah.
Thank you so much. We'll definitely look more into this great research. Well, I observed no other questions. So on this note, I would like to thank you for your time and your contribution, and looking forward to use these ideas for the rebuild. Thank you.
Thank you very much for the invitation, and all the best for everyone. Take care. Bye-bye.